So in this exploration, we're going to be using a URL signer to create a secure URL. And the way that we're going to do this is we're going to take the components of the URL that we want to lock down, and we're going to use those components to generate a signature that can be verified on the destination page in order to confirm that the URL has not been tampered with. In this case, we're going to be locking down this resource, which we're going to pass through as a query string parameter. We're going to be locking down this expiration date, which is a 20-second into the future expiration date. And we're going to be locking down the HTTP host. Now, every part of the URL that we want to lock down with the signature has to be included in the generation of the signature itself. Any part of the URL that is not included in the signature generation can, in theory, be tampered with without invalidating the generated signature. So we're passing in the host, the resource, the expiration date, and the signature. We then take that signature and we append it to the target URL. And you can see here that I'm passing through the resource, the expiration date, and then the signature as the thing that validates that the URL has not been tampered with. And we're just going to click here. And let's go to the browser and let's refresh the page. So we have this for 20 seconds. If we click on it, you can see that access has been granted. And if we do anything now to, let's say, alter the signature and add ZZZ, you can see that the signature did not match. This was the signature that we were provided with via the URL. This is the one that we were expecting. If we go back here and let's try to tamper with the expiration date. So we can just say that this is, instead of 5 here, let's go into the future 6. And you can see again, we have a signature mismatch. That didn't work. We can change this from 127 to localhost. And you can see again, the signature didn't match. And that's because the host, the expiration, the resource, those are all part of the signature generation. Now let's go back again. At this point, we've been going for more than 20 seconds, which means that this URL has actually expired. So let's go ahead and refresh. And you'll see it says expired link. Now the expiration date isn't inherently meaningful to the URL signature. It's meaningful in that it is a key value pair that gets added as part of the signature generation, but it doesn't have any business logic value. That's going to be handled after the URL has been validated. So let's take a look at the target page now to understand what we're talking about. So we're going to go into our view CFM here and look at how these query string parameters are being consumed. So in our view CFM, you can see we have our params here defining which URL components are expected, resource, expires at, and signature. We have to instantiate our URL signature. And for the demo, I'm not caching it. It uses the same secret key as the previous page, and that's because the signature generation has to be predictable. We have to be using the same secret key in order to validate that the signature was generated from a known resource. And to test the signature, all we're going to do is pass in all of those same inputs. So this struct here with the host, the resource, and expires at, if we jump back to our test page, that's the exact same struct that we're passing in here. The only difference with the test signature is that we're also passing in the signature that's been providing in the URL. So internally, what this method is doing is taking these inputs, regenerating the signature internally using the secret key, and then testing to make sure that internally generated signature matches the given signature. And if it doesn't, it throws an error. And that's what we were seeing on the screen previously. Now, as I mentioned, the expires at doesn't have any inherent value to the URL signer. It's just a key value pair. There's nothing meaningful beyond that. However, once the URL has been validated, meaning that we're confirming the URL has not been tampered with, at least the parts of the URL that we need to lock down, we can then further consume the URL provided parameters in a business logic sense, meaning we're taking that expires at date, we're checking it against the server's current tick count, and if it's exceeded the expiration, we're going to short circuit the evaluation of this page and say that the page is expired. And if the signature matches, if the URL is not expired, we can then go ahead and serve up the secure resource. I, of course, don't actually have anything to serve up, so I'm just saying access is granted. There's actually not a whole lot goes into the URL signing, so I will defer the exploration of this URL signer component to the actual content of this blog post. But I will say that URL signatures is a very nice and relatively easy way to lock down a URL, especially when the URL contains all of the data, meaning that there's not much of a persisted component to that data. I use it for things like passwordless logins and email tracking pixels. I first was introduced to this idea when I had to generate pre-signed URLs for S3, Amazon S3 object access. It's a very helpful tool to have in your tool belt. And I'll just finish up by saying that anything that you want to lock down has to be in that signature generation. So if we let's go back to the browser for a second. Let's close this and let's regenerate. And we come in here and I can come in and just say foo bar at the end and nothing bad happened because that foo bar wasn't a part of the signature generation. So this URL didn't care. You can do things like include the list of parameters that are available in the URL so that any additional parameter inherently or in some way invalidates the URL. So there's not a one size fits all here. You can make signature generation more complex or less complex depending on your needs. But again, overall, it's just a very simple, well, relatively simple mechanism for adding some security to your web application workflows.